indeterminate, right? You have to do the sum of forces x, y, and moments about z, and then you get to that assumption. Well, I guess that point, right?
Yes.
You can't just look at it and tell.
Yes, you can tell. Okay, by over here, how you can look. If you remove support at C,
Mm-hmm.
the structure is still it can still support itself. Yes or no? You don't need the support at C at all, do you? In reality.
Yeah, makes sense.
So it's a redundant. You don't need that at all. Okay, it's a redundant. So it's statically
So
indeterminate.
questions with double, I guess, loaded on both sides, you just jump right to statical indeterminate.
Yeah, yeah. Okay. Okay. So I think I've start recording again. Yeah, I've start recording again. Okay. Right. So if you were to compare, so we have 54, 133, 78.
Sorry,
So
sir,
if
there's another question in the chat.
do we need to flip it back at the horizontal? Do we need to flip it back to horizontal? Yeah, you need to flip it, but I'm doing down here. So at the end of the day, you just flip it back. Okay, your answers will still be the same. Okay, Pay, you understand that, Pay? What happened when we asked the maximum stress for, and yeah, so the maximum stress is this one. Okay, stress AB is the maximum stress. Okay, so if you ask about maximum stress, I don't know where the maximum stress also. I don't know. Okay, you have to check all of them. Jordan, does that answer your question, Jordan? Okay, right. So if we go back to the answer, 54, 133, 78. 54. Okay, 54, 133, 78. Okay, I mean 70. I think we got 78 point something, right? We're not that far away. Okay, the problem with their method is they don't tell you whether is it tensile or compression. We know whether is it tensile or compression. Okay, so we're more thorough than that. Right. So the next topic that we are going to go into. Okay, so the next topic that we're going to go to is thermal stresses. And thermal stresses, we need to get some information correct first. Okay, let me tell you what they are. Okay, so we are going to go into thermal stress. So the first thing that I want you all to take note. Okay, and when there is a temperature or when there is a temperature increase, okay, when there's a temperature increase, the change in length will increase. Okay, the change in length will increase. However, the stresses induced will be compressive. Very contradicting, yeah. Okay, I repeat again. When there's an increase in temperature, okay, so you put something into the oven, okay. When you restrict the motion, okay. So in general, when you increase in temperature, the length will increase, right? However, the stresses is compressive. Then you just say, Eugene, it just say the length increase. The only way for mechanical properties or stresses to when you increase in length is to pull them. Why you tell me this is compression? Okay, we will come into that. Okay, and when you grasp this into your concept, thermal stresses is very easy. A lot of times students struggle with this fact. Okay, that when temperature increases, you get compressive stress. So when temperature decreases or decrease, right? The change in length will decrease. Okay. However, again, the stresses induced in the material will be tensile. Okay. Again, two very contradicting statements down here, but it's true. So you guys know that extreme cold structures can fail also. Not just because of the glass transition temperature. So when it's too cold, okay, your material change from ductile to brittle. It's not just that reason, okay? Because when it's really cold, okay, you also will get failure, right? So like recently, not this time, our winter, like past few days was really cold, but I don't think any of us have any power failure so far. Okay, but when it gets extremely cold, like -30, -40, those overhanging cables to transmit your electricity sometimes will break. And then we ask ourselves why extreme cold will fracture these cables, and it does happen. Okay. Now, next one, the important thing to take note. Okay, important thing to take note. So there are these two theories that you have to grasp. Okay, the next one is very is I'm going to put star down here. Okay, there is no stresses okay, there is no stresses associated with temperature change. Okay, with temperature change, where there is no restriction of motion. Okay. So what do I mean by that? Okay. So the next time when you're on the freeway, okay, you have time. Okay, those of you might be in a motorbike or wherever, or if you have time, I want you to go below the freeway, okay, under a bridge and stop your car in the place that we could stop. Okay. And I want you to go and see how the bridge has been constructed. Okay. So most of the time, what you will see, I'm going to sketch a bridge. Okay. So this is a bridge. Okay. One end will restrict motion. Okay. This is one end of the bridge. Means the bridge cannot go towards the left anymore. Okay. It cannot go. On the right hand side, this is the support that you will see. Okay. Physically. And then if I were to draw this in something that you can understand, okay, on one side, so this is our side A, this is our side B. At A, what we have, okay, at A, point A, what we have is a pin. At B is a what? Is a roller. Don't expect when I mean, as mechanical engineers or manufacturing engineers, when we say the boundary condition is roller, this is when I was young, okay? I will go below the bridge to see where are the rollers. Okay? Don't look at it. You cannot see any roller. Roller means what? Okay? You allow motion going left and right. Okay, you allow motion. And why they design bridges like this? Okay, one of the reason is no stresses will be induced due to what? Thermal loading. Thermal loading means what? Change in temperature. Okay, change in temperature. Okay. So when you allow things to move, okay, when you increase the heat, you got no stresses. Okay, you got no stresses at all. Only when you restrict motion in the expansion or contraction region, then you will see what? Stresses. Okay, so I'm going to write this out. Okay, so as an example, okay, an example, if one end is built in and the other end is free. Okay, the other end is free, like this. Okay, so point A and point B. Okay, so the other end is free. And when there's a change, in temperature, okay, no stresses will be generated. Okay, because point B is allowed to move. Okay, it's allowed to move. Okay, so then in another example that I'm going to do now, if we restrict motion on both ends, so this is point A, now this is point B. Okay, now this is point A, now this is point B. Then we have our structure over here. Okay, we have our inbuilt structure over here. Right, now we restrict motion. Yes, we restrict motion now. Okay, so when we restrict motion, that's where we have issue. Okay, so when we restrict, so we talk about temperature change. Okay, we talk about temperature change now. Okay, so now, okay, before I go on, right, we realize that A and B will increase. I'm going to prove the point to you now. Okay, that when the temperature increase, okay, the structure will be in compression. So I'm going to write this down. Okay, temperature increase. Okay, AB is in compression, or stress AB is in compression. Okay, why is that? Okay, so what we're going to do now is like statically indeterminate structure. Okay, we are going to remove support at point B. Okay, so when that happens, so this is our point A, right? When we remove the support, because of temperature increase, what will happen?